Hello everyone, myself Raibi Singh. I am assistant professor in the Department of Mechanical Engineering at Amritsar Group of Colleges. So today's topic of discussion is graphical method to solve linear programming model. So a diet for a sick person contains at least 4,000 units of vitamin, 50 units of minerals and 1400 calories. Two foods A and B are available at a cost of rupees 4 and rupees 3 per unit respectively. If one unit of A contains 200 units vitamins, one unit of mineral and 40 calories, and one unit of food B contains 100 units of vitamins, 2 units of minerals and 40 calories. Find by graphical method what combination of foods be used to have least cost. So here we have to apply the graphical method to solve this linear programming model. So first of all, we have two foods, that is A and B, and they are available at a cost of rupees 4 and rupees 3 per unit respectively. Similarly, a food contains vitamins, minerals as well as calories. So first of all, we have to convert this model into a LPB model. So first of all, we are having two food, that is we are having food A as well as we are having food B. Okay, then we have unit contents of minerals, we have unit contents of vitamins, minerals and calories. So first of all we will write vitamins, then we have minerals, and then we have calories. So we are having vitamins, minerals as well as calories. Okay, so two foods A and B are available at a cost of rupees 4 and rupees 3 respectively. If one unit of A contains 200 units vitamins, okay, if one unit of A contains 200 units vitamins, one unit of mineral and 40 calories, one unit of mineral and 40 calories. So food A contains 20 units of 200 units of vitamins, 1 unit of mineral and 40 units of calories. Similarly, 1 unit of B contains 100 units of vitamins, 1 unit of B contains 100 units of vitamins, 2 units of minerals, 2 units of minerals and 40 calories. So the number of calories of unit A and B are same, and 40 calories. Okay. Two foods A and B are available at a cost of rupees 4 and rupees 3 per unit. So they are available at a cost of rupees 4 and rupees 3 respectively. So in this way, we have formulated the given problem into a LPB problem. So a diet for a sick person must contain at least 4,000 units of vitamins and 50 units of mineral and 1400 calories. So the minimum requirement of vitamins is 4,000. Minimum requirement for minerals is 50 and minimum requirement of calories is 1400. Okay, so this one is the minimum requirement. The minimum requirement of vitamins is 4000, minimum requirement of mineral is 50, and the minimum requirement of calories is 1400. So what combinations of food must be used to have at least cost? We have to find the minimum cost. Okay. So convert this table into equations. So the total requirement of vitamins is 4000. Let x1 will be the number of units of A and x2 will be the number of units of B. Let x1 be the number of units of A and x2 will be the number of units of B. So 200 multiplied by x1, 200 multiplied by x1 plus 100 into x2. So this is the total requirement of vitamins, 200 into x1 plus 100 into x2. But the minimum requirement is 4000. It means 200 into x1, 200 into x1 plus 100 into x2. This must be greater than equal to 4000 because the minimum requirement of vitamins is 4000. It means this value must be greater than equal to 4000. Similarly, the requirement of minerals is 1 into x1, it will be x1 plus 2 into x2, this will be greater than equal to 50. x1 plus 2 into x2, this must be greater than equal to 50. Similarly, the requirement of calories are 40 into x1 plus 40 into x2, this must be greater than equal to 1400. So 40 into x1 plus 40 into x2, this must be greater than equal to 1400. And the minimum requirement is z will be equal to the cost function. Z will be the cost function, and this will be equal to 4 into x1 plus 3 into x2. So the value of z will be equal to 4 into x1 plus 3 into x2. So z will be equal to 4 into x1 plus 3 into x2. We have to minimize this value and it is subjected to constraints. 200 into x1 plus 100 into x2, this must be greater than equal to 4000. In this equation, 100 will be common term. So this equation will become 2 into x1 plus x2. This will be greater than equal to 40. Similarly, the second equation is x1 plus 2 into x2. This is greater than equal to 50. Similarly, we can simplify the third equation also. So third equation will be, here 40 will be common, x1 plus x2, this will be greater than equal to 35. So these are the three equations. First one is 2 into x1 plus x2, this is greater than equal to 40. Second one is x1 plus 2 into x2, this is greater than equal to 50. And the third one is x1 plus x2, this is greater than equal to 35. Now we have to convert the inequality sign into equality sign so that we may use the graphical method. So these equations can be written as 2 into x1 plus x2, this will be equal to 40. The second equation is x1 plus 2 into x2, this will be equal to 50. And the third equation is x1 plus x2, this will be equal to 35. Now the next step is Put the value of x1 is equal to 0 in equation number 1. Let this will be equation number 1, this will be equation number 2, and this will be equation number 3. So put x1 is equal to 0. 0 plus x2 is equal to 40. It means the value of x2 will be 40. So point A will be 0 comma 40. So point A will be 0 comma 40. Similarly, put x2 is equal to 0. Put the value of x2 is equal to 0 in this equation. 2 into x1 will be equal to 40 or x1 will be equal to 20. The value of x1 will be 20. Let this is point B and this will be equal to 20 comma 0. So equation of line number 1, that is 2 into x1 plus x2 is equal to 40. This will be given by points A and B. So the value of A is 0 comma 40 and the value of B is 20 comma 0. Similarly, for second equation, put the value of x1 is equal to 0. In equation number 2, 2 into x2 is equal to 50. So the value of x2 is 25. And let this is point C. It will become 0 comma 25. Now put the value of x2 is equal to 0. We can get the second point. Put x2 is equal to 0. So x1 will be 50. So x1 will be 50 and let this point will be equal to 50 comma 0. Similarly, put the value of x1 is equal to 0 and x2 is equal to 0 in equation number 3 and we will get 2 points. Let the points will be E and F. So put x1 is equal to 0. Similarly, put x2 is equal to 0. When we put x1 is equal to 0 in this equation, the value of x2 will be 35. The value of x2 will be 35. So the point will be, this will be 0 comma 35. Similarly, when we put x2 is equal to 0, the point will become f will be equal to 35 comma 0. Now we will plot all these values on a graph. So the point A is 0 comma 40 and point B is 20 comma 0. Point C is 0 comma 25, D is 50 comma 0, E is 0 comma 35 and F is 35 comma 0. So the first 2 points represent equation number 1. C and D, this will represent equation number 2, and E and F, this will represent equation number 3. Now we will plot these points on a graph. So first of all, take x1 along the x-axis and x2 along the y-axis. So the first point is 0 comma 40. The value of x1 is 0 and the value of x2 is 40. So this is point A. The second point is B, 20 comma 0. This is here the value of x1 is 20 and the value of x2 is 0. So this point will be B. So join A with B. Okay. The line AB represent equation number 1. It is 2 into x1 plus x2. This will be equal to 40. Similarly, the coordinates of point C are 0 comma 25. So this is point C and the coordinates of point D are 50 comma 0. So this is D. So join C with D. This will be equation number 2, that is x1 plus 2 into x2. This will be equal to 50. Now the coordinates of third equation are E is 0 comma 35. This is point E and 35 comma 0. This is F. So join E with F. Okay. So this will be equation number 3. So AB represents line AB represent equation number 1, line CD represents equation number 2, and line EF, this will represent equation number 3. Line EF, this will represent equation number 3. So the coordinates of point A are, the coordinates of point A are
0, 40.
0, 40, the coordinates of point A are 0, 40. Similarly, coordinates of G are 5, 30. The coordinates of point H are 20, 15, and the coordinates of point D are 50, 0. So these are the coordinates of point A, G, H, and D. Now we have to find the minimum value. Okay. So first of all, we have to draw a table. In the first column, write down corner point. Then there will be coordinates of the point. Then we have objective function, that is Z. Here it is cost. We have to minimize the cost. In the third column, we have to write the objective function, and in the last column there will be the value. So there are 4 corner points. They are A, G, H, and D. A, G, H, and D. The coordinates are 0, 40, 5, 30. The next value is 20, 15, and the last value is 50, 0. The first value is 0, 40, second one is 5, 30, third one is 20, 15, and the last value is 50, 0. Now we have to find the value of Z. We know that Z is equal to 4 into x1 plus 3 into x2. Z is equal to 4 into x1 plus 3 into x2. So simply put the value of x1 and x2 in this equation, and we can calculate the value. So the first value will be Z is equal to 4 into x1, that will be 0, plus 3 into x2, so it will be 3 into 40. The value will be 120. Similarly, the second value will be Z is equal to 4 into x1, 4 into 5, that is 20, plus 3 into x2, 3 into 30, that is 90. The total value will be 110. Similarly, the third value is Z is equal to 4 into x1, 4 into 20, that is 80, plus 15 into 3, 45. The value will be 125. And the last value will be 4 into 50 plus 0. 4 into 50 plus 0. The value will be 200. So the value of objective function, that is cost, is for A it is 120. For at point G the value will be 110. At point H the value is 125, and at point D the value is 200. Now we have to find the minimum cost. So the minimum value is 110, and it is at point G. So the value of Z is 110 at point G. The coordinates are 5, 30. So at this point the value will be minimum.